So during the past 4 years, we have been working in a European-funded project. I'm going to introduce that later on, called PITHIA-NRF. And we have been developing a so-called eScience Center, which supports the work of the targeted domain scientists. So this particular presentation will be about this work, and will summarize what kind of solutions we developed. The relevance to the EGI seminar series is that EGI is a partner in PITHIA, and we have incorporated quite a large number of EGI services into the implementation of the Science Center. So I will very specifically highlight those at the end of the presentation. So first, just a few words about, I'm trying to get rid of this banner at the bottom. Yeah. Sorry. Okay, so first, just a few words about the scientific background, and you have to excuse me because I'm not a scientist doing this particular research and working or active in this area. So my knowledge about ionosphere, thermosphere, and plasmasphere research is very close to non-existent. The only things which I picked up probably are buzzwords, which I picked up during the lifetime of this project. But otherwise, we are not. With my team, we are not domain scientists. So what we understand is that the eScience Center collects information and data collections, prediction models about ionospheric, thermospheric, and plasmaspheric research. And in my very, very primitive interpretation, this is practically everything or almost everything between the Earth and the Sun. And I know that there are scientists here in this call because I checked the participant list. So they probably freak out now, and I will stop talking about this anymore because, again, this is not my area. So what I'm going to explain is that what kind of solutions we developed for the scientists and how we are supporting their work in a way that we don't necessarily have to understand how the tools are working or what scientific message or knowledge they are representing, but we provide a generic environment which they can use in order to support their scientific work and activities. And I think you can understand that this was a very difficult journey, obviously, because we haven't spoken each other's language. So they didn't speak computer science and I don't speak space physics. So it is not an easy task, and if you have been in similar projects, I think you realize that this is a very, very difficult and a very time-consuming task in order to specify what needs to be done and to do it properly. And I believe that we achieved it in the end, which is a very good thing. The project is ending in June this year, so we have a few more months to do the final touches, but what you are going to see today is more or less the final results of the project. So this is just a short introduction about the PITHIA-NRF project. So as I said, we are supporting plasmasphere, ionosphere, and thermosphere researchers all around Europe. And the aim of the project is to build a network of research facilities that are all related to this particular research activity. And the project in general would like to integrate various observing facilities, data collections, data processing tools, prediction models, and so on, which are at the moment scattered around Europe, or at the beginning of the project were definitely scattered around Europe. And there was very little interaction, even very little knowledge about what is existing in the various sites. So the duration of the project was a little bit more than 4 years. So we are finishing at the end of June. It was a kind of small to medium-sized European project, so 5.4 million is not a specifically big project, but I think a very healthy budget. And we had 22 project partners. 20 of them were scientific partners, so they were all space physicists. And the two technical partners were the University of Westminster and EGI. And practically the work distribution was that Westminster's team developed the Science Gateway, the eScience Center, and EGI provided support with the integration of EGI-related services, or even the further development of those services to fit the requirements of the the project. And I think the collaboration worked out quite nicely, as you are going to see in the results. So what I'm going to focus on is not the project in general. As I said, I'm not a domain scientist, so I can explain very little about the scientific background, but I do understand the PITHIA Science Center because the team at the University of Westminster has developed that. So we are going to focus on the PITHIA Science Center, which is by definition a kind of central web portal to provide a single point of entry to heterogeneous and distributed resources related to this particular domain. And these resources, and this will be a little bit surprising probably when I discuss the definition of this. So these resources at the moment are put into 3 different categories. So the biggest category is what this community calls data collections. And data collections can be different types. They talk about activity indicators, sensor measurements, computational models, annotations, and other, or a mixture of these various categories. But what is important, or what is interesting, is that we understood that data collections are defined in a slightly different way how a computer scientist like I would define a data collection. For me, a data collection is a collection of data. And in the PITHIA sense, it is not only that. So we call data collections data sets, which is very close to what I would call, but we also call data collection a prediction model, which runs a particular computer science code and on the fly returns some results, for example, a file or a value or a diagram or a picture and so on. So the execution of prediction models also in the category of data collection. And I think this is a little bit surprising at the first hearing. At least for me, it was surprising. For the community, it was not, because this is what is their notion of data collection. So this could be something which is collected by sensors, but this could also be something which is computed, pre-computed by a model, or it could be a model which is on the fly computes certain results. They also talk about static data sets. So these are data sets which are never changing. Data collections are typically dynamic. There is an instrument, and that is conducting thousands or sometimes hundreds of thousands of measurements a day, and then sending it to the data collection. A static data set is something which is related, for example, to an academic publication, to training a machine learning model, to a particular event which happens. So, for example, a solar flare eruption happened on the sun on a certain date, and that's never going to change. So that remains static. And that's why they call it static data sets. And we also differentiate between workflows. So we support the creation of workflows and the execution of workflows, which are combining multiple data collections into one kind of self-contained and executable entity. I'm going to talk about workflows later on in a little bit more detail. A very important aspect of the PITHIA Science Center that this is based on a standardized metadata and ontology. And again, I'm going to introduce this in the next slide very briefly. It provides integration with all the registered resources. So all the providers within PITHIA are integrating with this central hub. And the eScience Center is available and freely accessible at this link. So if you are interested, you can just put it into the browser and you can go there and you can see how it looks like. I'm going to explain what is completely open in the eScience Center and what are those activities where you need registration. So let's start talking about the eScience Center and a little bit the background or the philosophy of the eScience Center. As I mentioned, the eScience Center is based on the PITHIA ontology and metadata structure. This is originated from a previous Horizon 2020 project, which the community was conducting. They there developed a metadata structure and an ontology, which was then modified, mainly simplified but also in many cases very significantly modified for this particular project. And we created this PITHIA metadata and ontology structure. Now, what is the idea behind this? Is that we use, or rather the community uses, an XML-based ISO standard, which is called ISO standard on observations and measures. And they use this particular standard in order to describe various entities or various metadata about the data which they store in the eScience Center. And based on this standardized format, they created a metadata structure which includes 12 different steps or 12 different entities for data collections. For static data sets and for workflows, this is significantly simpler. So in that case, because they are combining already registered things, this kind of hierarchy is much, much smaller. But I wanted to show you the most complex aspect of this, which is the data collections. So in case of data collections, when they register a data collection in the eScience Center in the form of an XML document, then they need to describe that data collection in full detail. And that means they have to tell what is the organization where it belongs to, who is the individual who is responsible, or individuals, which project created it, what platform, operation, instrument belongs to that, how the data is computed or acquired. Acquired means that they observe the data and then they collect, and computation means that this is the result of some sort of computational model. So they need to provide all of this information and describe the data in full complexity. Now, when they do this, what makes it even more interesting is that they cannot just use any kind of free words when they are describing the data, when they are describing, for example, computation types, or when they are describing platforms and so on. They have to use keywords from the space physics ontology, from the PITHIA space physics ontology. So the ontology defines certain keywords, and then when you describe certain events, certain things, then you need to use the predefined keywords from the ontology. I'm going to explain how we make it a little bit more easier to scientists, because obviously this has a relatively big complexity, and this complexity is shown on this figure. So the blue boxes, you can't see this and you don't have to read this, but the blue boxes represent the metadata from the ontology. So this is the kind of complexity what we are talking about. Obviously, this is complex for those who are registering the data collections, but as you will see, it will make the life of the actual scientist much easier, because they have a very rich set of metadata available, and the eScience Center supports search functionalities based on this complex set of metadata. So when I start talking about the eScience Center, this is what you can see if you go to the website URL of the eScience Center. So you can see that there are various functionalities supported. This is part of those functionalities, not all of them. And there are functionalities which are available for everyone. So if you go to the main page of PITHIA without logging in or without authenticating, then this is what you are going to see. And all of these functionalities, every data set is fully open to anybody who goes there. So you don't have to spend any time on searching for data. You don't have to register to search for data collections, to browse the space physics ontology, to see a guide about registration and registering new data, and so on. However, if you are a data set owner, or if you are a data owner, then in order to register something in the eScience Center, you need an account. You need to belong to an institution in the eScience Center, and you need to authenticate, and you need to have authorization in order to publish that data. So this particular functionalities, with the very exception of the registration guide, require authentication and authorization. And this is, for example, something which we got very huge support from EGI because we use EGI check-in and the Perun authorization system, and that is the basis of this implementation. So we didn't have to start the user management implementation from scratch. We got these features from EGI. Some features were missing, for example, from Perun, which they very kindly implemented for us, and we could implement this quite sophisticated user management system. I will talk about the user management system in a little bit more detail later on. But what is important is that if you are a publisher, then we need to know who you are. If you just would like to access the data as a scientist or an individual or a citizen, you can get access to the data. But if you would like to publish new data, obviously we need to have some certain level of trust in who you are and at which institution you represent. So this presentation will not tell all the functionalities of the eScience Center. It is just a few highlights of what are the most important features. So first of all, you can browse our data collections. At the moment, we have 68 data collections published. This number is growing. So a week ago, I had another presentation and we had 61. Now we have 68. So this is obviously kind of dynamically growing, definitely until the end of the project, and hopefully after that as well. So if you click on this browse page, then you will see the various categories of data collections, which I have already mentioned, from activity indicators to computational models and so on. And then you can see listed here the various data collections which are registered under that particular category, or you can search by a very simple search. You can search by the name of that data collection, and then you can jump to that data collection immediately. So this is one way of finding a data collection. Obviously, at the moment, it is probably working well because we only have 68 data collections. If we would have like 2,000 or 10,000, hopefully we will reach that in the future, then it would be a little bit more complicated, obviously, to use this browse. But if you know what you are using for, you are looking for, then this may be something quite useful. The second way of finding a data collection is using something which we call a simple search functionality. So this is the simple search functionality, which searches for a keyword, but not only in the name of the data collection, in the entire XML tree as it was registered. Okay? So when during registration, people provided metadata, going down those 12 steps potentially, and providing metadata, every single keyword in this XML tree is searched, and then the result is displayed on the screen. So for example, I put in a keyword of KP index, and then the eScience Center returned all those data collections where KP index is appearing in the XML tree registration of that particular data collection. And obviously, once you found the data collection, I will show it later on, you just click on that, and then you will get more information and you will get access to the actual data as well. So, as I said, all the data collections are appearing on the screen. Now, if the previous was kind of mildly exciting, then I think the most important or the most exciting feature is the most advanced search feature, which we call content-based search. And this is based on the space physics ontology. So that means that you can search by feature of interest. So what is the what is the interest of your observation? You can search by computation type, instrument type, and annotation type, and you can search by what we call observed properties. And each of these are drop-down boxes. So if I drop them down, that are similar to this kind of drop-down menu appears. And you can combine these searches with each other. So you can select something from feature of interest and something from observed properties, and then you can find the combined features of that. So for example, if you are searching for data collections related to the heliosphere, then you tick this box, or you drop it down, and then you can go into more details regarding that. And then the search will return all those data collections which are related to your ontology-based combined search. And then, yeah, you just press the button and the results will be returned. So these are the three ways of finding a data collection: either browsing it and just knowing which one you are looking for, or looking for a keyword in the XML tree, or using the ontology based on that search screen in order to find the data collection. Now, once you found the data collection in either ways, the result will be the same. You will be directed to the data collection, and then you can read more about the data collection. So first of all, you can find some basic information. This obviously depends on what the scientist provided. Please note that none of these are made up by us. So this information, all this information on the page is coming from the XML registration documents. So everything is dynamic. If there is a mistake there, then we ask the owner of that data collection, please correct the file because somebody would like to get more information or longer description, and that is the way of doing that. And obviously after that, the Science Center will automatically display the correct information. So you can find some basic information about the data collections. You can find links to access the data collection. In this particular case, the link takes you directly to the data collection. So you just click on the link, and then it will take you to the data collection. And then if you are a more advanced user, you can also get further information. So for example, the related metadata. So you can actually get access to the XML documents if you want, further information about resources, permissions, how to access the data, what are the limitations of accessing the data, Creative Commons license, for example, and so on. So the next step, obviously, is that if you would like to access the data, you click on the link. And based on the data collection and how it is registered by the owner, you will get access to the data. So, for example, in this case, the link directly takes you to the data itself. So this is in a public repository, and this is the way how the data is stored. It is stored by years, and then you just click on the data and you can directly download the data or browse the data on the screen. But again, this access method depends on how the owner of the data collection published it. They have various ways of doing that. You will see different examples in the next few slides. So to show you a different example, this is another way of accessing a data collection. This data collection is actually a computer program. So this is a simulation model. They call it BSPM, 3D Kinetic Plasma Sphere Model. And what it is doing, it is taking certain inputs, computing some predictions, and then displaying the results of that prediction in the screen. If you would like to know more about what it is computing, then you can read a description of that. I'm not going to read this out. As I said, my understanding about this is relatively limited. But obviously, if you would like to understand what the model is doing, then you can read even more information if you go to the screen about the model itself. And then if you would like to execute the model, then you just simply click here, and you can execute the model from the PITHIA Science Center through an API. So let's see how it actually looks like. So if I click on that particular button, I find a link to execute the model. Then this is what you are going to see. So for those who are more computer-minded, just a little bit of background how this works. So this is a fast API-based Swagger UI interface, which we customized. So the Swagger UI interface is customized for PITHIA, so it has the same look and feel for every model which is published in this particular way. But we generate this automatically. So the user interface is not custom. We take the fast API description of the model, of the API of the model, and then we automatically generate this graphical user interface out of that. So the graphical user interface shows the various functionalities, the various endpoints of the API. In this case, you can execute the model, retrieve executions, draw a plot, or download the results. And when you select the desired operation, so for example, I selected plot because that's the most colorful one, so I thought that for a presentation that would look good. Then it displays what input this model requires. So this requires two input parameters. One is a date, another one is an hour. It could require much more complex. It could require a file, for example, as an input, or anything which is required for the model. And after that one, I can run the model. And once I run the model, then I receive the output. And in this particular case, this is the output of the model, which is displayed on the screen for the scientist. But again, this could be very, very different from model to model. And that's the beauty of the Fast API and Swagger UI-based implementation, that we don't have to create custom interfaces. A very, very large types and numbers of models can be supported with this kind of interface in a relatively user-friendly way. I'm not saying it cannot be more user-friendly, but I think comparing the effort which is required to add a new model, it's a reasonable graphical user interface. And if somebody would like to add a new model, then only the description of the API of the model is required, nothing else. And these APIs are either hosted on EGI, so we have dedicated servers on EGI where the model APIs are hosted, but they can also be hosted externally by the partners. So it's not a requirement that they must host their APIs on EGI, but that's an option, or that's a possibility. So the next one, and I think this is quite interesting, and I think what was interesting for us is the journey to this, and where we are currently on this journey. So the next thing is to execute workflows. And I don't know how much you are a scientist, or you worked with computer scientists as a scientist, or the other way around, with scientist as a computer scientist. It's not an easy discussion, and not an easy kind of thing which we need to do. So we were keen on introducing workflows to the community, because we had a belief that this could be something useful for them. But obviously explaining what a workflow is, or even more making them aware that this is something useful for them, it's not a straightforward task. I mean, we said, yeah, okay, we are going to develop workflows, and tell us ideas. What kind of things you would like to combine into a workflow. And the answer was a complete silence. So we haven't received anything at all. They said, yeah, it sounds like a good idea. Do I have a workflow? I don't think so, or I don't know. Okay, so this was a very, very complex journey. And because of that one, we decided that at the beginning, we are not going to use a widely used workflow engine or workflow management system. Because the problem was not to implement the workflows. The problem was to identify whether they have workflows at all, or whether they don't. There were some members of the community who said, yes, this is good, we have workflows. The others said, no, we don't have workflows. They don't exist. Don't even bother. Don't spend time on this. So we were not sure whether it will be something useful or not. So the current workflows are based on scripting. So they are just scripted together at low level. We develop the workflow and we script it together. It seems that finally, towards the very, very end of the project, it starts to pick up. So just to give you an illustration, for the first year we had, for the first 2 years, or almost 3 years, we had one workflow. And after that, we had 2. Now we are talking about having 8 by the end of the project. So it kind of exponentially picks up, which makes us believe that the community finally understood what is the power of this, and how they can utilize this. And they now have this thinking that, yeah, I can put together a workflow, and this would be pretty cool of doing that. So in a workflow, they can combine multiple data collections, and they can put it together in an automated way, as you can imagine, and then they can execute it by one click of a button, which makes many tasks much more simple than otherwise it would be. So in case of the workflow, the logic is the same. Find the workflow, learn about the workflow. You can even download a kind of graphical representation of the workflow. So this is a workflow graph of one of the workflows which they created together with us. And then execute the workflow, and the execution logic of the workflow is exactly the same what we used in data collections. So we use Open API specification, we use Swagger UI, and then we generate a graphical user interface in order to execute the workflow. But it is not executing one single data collection, it is executing all this complexity of a data collection. And then they can just see and visualize the results of the workflow. So this was about the main functionalities or the user-facing, the scientist-facing functionalities of the eScience Center. I also wanted to talk a little bit about resource management, how the resources are published in the eScience Center. So data collections, workflows, static data sets are all published, as I already explained, through this 12 or less step process where they publish the XML description files of the data collection, data set, or workflow. Now, at the beginning, we started with a manual XML upload, so they needed to edit these manually. At the beginning, actually, what we received as feedback is that, yeah, that's fine with us. We are familiar with these XML files. We used it in another project, and we can manage this. You don't have to worry about that. But then more and more users came forward and said, well, we are actually not that familiar. And this is a big burden for us. This holds us back. So in the second half of the project, we implemented something which we call the registration wizard. And even the big gurus in the end said, yeah, this is cool. So this is even for us much simpler than editing the XML file. So the XML file editing and uploading functionality is still there, and people can still do that, and many people still prefer that. But we also implemented the wizard. And why the wizard is easier, that in the wizard there are multiple ways of completing the various fields of the XML file, which is then generated automatically. So one way, obviously, is that you type in the information. So for example, data collection full name, we can't really help you in this. Yes, this is however you call your data collection. So this is something which you need to type in. But in some other cases, we can help you with drop-down boxes. So for example, organization associated with the data collection, this can only be an organization which is already registered in the eScience Center through the user management system. So this one, we can easily create a drop-down box and they just select the right value. They can't mistype and so on. And there are some other information, like, for example, previously in the XML file, they needed to provide a namespace. Now, this one we can generate automatically. So that means that with some convention, we generate these fields automatically, so they don't have to worry about that. Once the above information is completed, then the namespace information will be automatically generated. Yeah. So it's also said in the instructions that this is done, and this turned to be a big kind of help for them because registration became much simpler than it was before. And once they registered everything, for example, they need to register also if this is registered with an API, then then a link to the API, Open API specification needs to be provided, or a description of the API. And once they click a button, then the XML file will be generated automatically and will be validated. And validation is a 4-step process. So we validate whether the syntax of the XML is correct. We validate whether the XML conforms to the XML schema, which is defined. We validate whether the XML conforms to the ontology. So all the keywords are coming correctly from the ontology. And it is also validated whether it is in the 12-step process refers to things which has already been registered before. So for example, if you refer to an organization or to an individual, or whoever does not exist, that's not possible. Obviously, in case of the wizard, it's not possible to enter such values. But if you upload manually an XML file, then you can make a mistake in those cases. So I very specifically wanted to highlight towards the end of this presentation the services which we use from EGI, because I think those were very, very helpful and made the implementation more robust, more sustainable in all of the cases practically where we used it. So first of all, we use EGI check-in for user management and Perun for authorization. Okay, so authentication is done through EGI check-in, so we get all the advantages of they can use their institutional logins, for example, or Facebook accounts or whatever for the authentication. And again, a huge thank you for the Perun team, because they did a tremendous job to accommodate all our crazy requests. So it turned out that we needed to use Perun in a way, in a level of complexity how it was not used before. So a lot of developments and changes have been done by the Perun team in order to accommodate that, and I think we came up with a fantastic solution in the end. We also integrated the EGI GIGAS system, and as I learned from Yin recently, we are the first one ever who have done this at community level. So again, this was not straightforward, because we wanted to use GIGAS again in a slightly different way as others are using it. So we are this kind of very first pioneers in this extent. We also use the EGI Data Hub. So data management and storing files is happening through the EGI Data Hub. And of course, at the core, we are using virtual machines from EGI, from the IN2P3 site in France, to host all the virtual machines of the Science Center. You will see that complexity in the next slide, and host the core services and so on. So everything is based on this cloud-based infrastructure. And this is the complexity, the technical complexity behind the eScience Center. So you see that we use the external EGI services like GIGAS, Check-in, and Perun for various purposes. We also have the core eScience Center. So we have a metadata server, we have the application server, we have a data repository, and we have an eScience Center central database, and these are all hosted on the IN2P3 site. And these are also connected to external providers. So the 20 PITHIA partners are all providing access to certain data models. They may host APIs to access their models and so on. So this is the entire complexity, and this upper bit is the one which is EGI specific. Obviously, these are typically outside the EGI or even the Science Center domain. So thank you for your attention. I'm sorry that I was a little bit longer with the presentation. I think we have still like 30 minutes for questions, or if there are less questions, then I can also show the Science Center in action a little bit. But I think it's probably worth going back to questions first.
Thank you so much, Tamas. And it's such an impression. All this long way comes through. I remember for these years, but a great congratulations for this excellent work. And I think this advanced in co-design with the community and for the community, and it's a great achievement. And any question for Tamas for the mainly? I think we learn a lot about the designing for community service, and as a very valuable knowledge. Any question to Tamas? And we have around 10 minutes, and if there are no question, and we can see a little bit demo, I guess that would be interesting. What do you think, Tamas? Or
if there are no questions, I'm happy to show a demo. So I just didn't want to take the time away from questions if there is any.
I guess people can take some time to think about it, and while we see the demo, they may come some question.
Okay, so I will then reshare my screen. Just give me 1 second. Okay. Yes. So this is the Science Center main page. We are currently working on a kind of quite big redesign. So maybe in a few weeks or months' time, it will look different. The content will not change that much, but the look and feel we are thinking about slightly redesigning it. So as I said, there are various search functionalities, and probably the most interesting one is the ontology-based search, which I have shown. And again, I will probably do a silly search because as I said, I'm not really a scientist here, or have no knowledge about the background of this. So it's a very simple search functionality where you can go through the various aspects of the ontology, and then you can select and tick boxes regarding the aspects. And again, I'm just kind of randomly clicking on something. Where you see a text in black, that means that this is something where we have data collections. And where you see it in gray, that represents that we don't have any data collection which refers to that category, but this is included in the ontology. So we don't have, for example, interplanetary mediums at the moment registered in the Science Center. And once you selected this, then you press search, and then all those data collections, I managed to do something which returns a very large number of data collections. So this is 29 out of the 68 data collections fulfills this particular search criteria. So this is something which could be interesting. I thought that I also show you the execution of a data collection and the workflow. So for example, if I go to the data collections and I go to computational models, then this was the first computational model which we have integrated with the Science Center through an API. So this is called DTM 2020, or semi-empirical thermosphere model. And again, you can read the description. I think this has a relatively detailed description, and I assume that this is something which is easily understandable and meaningful for the domain scientists. And if they would like to execute the model, then they click here, and again, they see a short description of the model, and then they can do various things. So for example, they can execute, draw a plot, or download the results. And there is some help also. So if they would like to know what the various parameters mean, then they can get some information. So if I go to execute in this particular case, then the default values are already provided, and this is a huge help for me because I personally at least don't have to think about what to select. So I'm going to execute the model with the default values. And if I execute it, I will get this JSON response. And this could be, so the values could be important, or the results could be important for the scientist. But what is important is that I need to remember this workflow ID, data collection ID or execution ID, because this particular application is implemented in that way that if I would like to draw a plot, which is the next functionality, then I need to provide an execution ID for which execution I would like to get the plot, which parameter I would like to see. So I stick with helium, and then I can just run the plot and see a kind of quick view plot in the Science Center. So that is a sample execution of a data collection. And if I would like to execute the workflow, the complexity does not really change. So I think that's very important, that from the user's point of view, the complexity of the workflow is not much different from executing data collection. Obviously, in case of the workflow, the diagram is slightly different. So this is, for example, what we have seen in the presentation as well, that this shows the workflow diagram. But then if I would like to execute it, I just click on the button, and a very similar user interface. Oh, sorry, not that button. That was the wrong button. Yep. So I need to click to the button to run this workflow. And then you will see that the user interface is very similar to the previous one, because this is again generated automatically by Swagger UI. But as I said, we customize Swagger UI. So this looks like a PITHIA Science Center page pretty much. And it does not confuse the user that now I'm seeing something completely different. And in this case, the plotting and the running is combined. So it's implemented in a slightly different way than the previous workflow was implemented. So I just need to provide a date for this one. And I need to select a station where I would like to get the information and select a couple of characteristics. So I'm just copy and paste these characteristics, which I would like to see on the workflow. And then I run it. And then you will see in a few seconds, hopefully, you will see the results of the workflow. We are working on new versions of this workflow already. And as I said, it has accelerated in the past few weeks. So we have larger and larger number of workflows available. And the scientists are coming up with newer and newer ideas. So hopefully in a follow-up project, we can integrate a nice workflow engine into the Science Center, because then they will reach the level when it will be really the bottleneck how to implement the workflow, not to come up with the idea of the workflow. So with that, I think I am running out of time, so I would like to finish it here and give it back to Yin and to any questions which still remain.
Thank you so much, Tamas. Any question from our audience? Excellent work. And if I do not see any hands, you can also, I do not see anything in the Q&A box. And okay.
I don't see that. Yes, I'm just checking whether there are no questions in the Q&A box. Neither in the chat. So it's
yes. With this, I would just thank Tamas again for his excellent talk. Most importantly, his excellent work. Also, thanks to today's participant. Thank you for your participating. Thanks for Federico, who is behind the scene to support us. And thanks very much for everyone. And hope you enjoy the rest of the afternoon, and see you next time.